A unique approach to data privacy. Differential privacy. How does it work? Differential privacy measures the degree of privacy lost, or epsilon, when a dataset is randomized or has noise added to it. The value of epsilon is dictated by the relationship between data privacy and potential data use. The lower the value of epsilon, the more privacy is retained. However, this also means the overall business utility of the dataset is compromised. Compliance with data regulation. Privacy breaches or regulatory infringements can result in extremely costly fines. Amazon was fined a remarkable $877 million just last year, while other major tech corporations like WhatsApp and Google Ireland also received penalties in the hundreds of millions. When such penalties occur, they damage the reputation of an organization and also reduce the level of trust consumers place in their services. While it is unlikely that consumers will abandon digital services of convenience anytime soon, the companies could still see a decrease in growth and overall revenue. Differential privacy does not conclusively solve the issue of data compliance and regulation at the enterprise level, but it provides an avenue that organizations can follow to maintain the accuracy of their datasets without compromising consumer or corporate privacy. Quantifying privacy. There are two primary issues with quantifying privacy. One, there is no predetermined threshold for what an acceptable value of epsilon is, and two, differential privacy can only be quantified at an aggregate scale. Small datasets cannot be anonymized in this way because they lose all utility. Unfortunately, there is no agreed upon standard for what the minimum or maximum threshold value of epsilon should be. It is up to companies to self-regulate and establish industry standards, although it would be naive to assume that these standards would prioritize privacy over data utility. While major tech corporations may be able to implement differential privacy due to the scale of data they use, smaller businesses and enterprises have to deal with the risks posed by linkage attacks and their abilities to comply with regulatory frameworks. If they cannot obtain large-scale datasets, it will hinder business expansion severely, possibly to a point where all market advantage is lost. Why is differential privacy a better option than other data privacy approaches? Current data privacy approaches involve a variety of methodologies, such as pseudo-anonymization, sophisticated encryption using tools like Block Cipher Advanced Encryption Standard, AES, or the Triple Data Encryption Algorithm, DES, and more. Differential privacy allows organizations to take on a novel perspective that does not require data to be intrinsically protected, but rather manipulated to a point where it retains its utility without risking the exposure of sensitive information. The advent of differential privacy has also inspired new and more secure approaches to the generation of synthetic data. Thank you for watching.